Every instrument on a ship's bridge, from the most advanced electronic gyro to a traditional magnetic compass, is vulnerable to mechanical drift over time. To guarantee your heading is true, we can check the compass against something that never drifts: the sun. By taking a visual observation of the sun at dawn or dusk, we can determine exactly how far off the compass is. In this video, we will walk through exactly how to take a bearing, run it through a simple formula, and extract an exact compass error. Before we begin, you need 5 items: an observed bearing of the sun, the exact Greenwich Mean Time of the observation, your ship's dead reckoning latitude, the current year's nautical almanac, and a basic calculator. Once you master this essential celestial technique, you eliminate the danger of relying solely on drifting instruments, ensuring constant directional accuracy for your vessel. Step 1 is to measure the compass bearing of the sun precisely at sunrise or sunset. This diagram shows the difference between where the sun actually is and where it appears to be. Because the Earth's atmosphere bends light, a phenomenon called refraction, the visible horizon sits lower than the theoretical horizon. To account for this distortion, wait to take your bearing until the sun's lower limb sits roughly 2/3 of a diameter above the visible horizon line. The moment you take that bearing, immediately record the exact Greenwich Mean Time, or GMT, and note the ship's current dead reckoning latitude. Taking the observation at this precise height compensates for atmospheric refraction. Doing this prevents a calculation failure before the math even begins. Next, open your nautical almanac for the current year to the exact date of your observation. Find your recorded GMT hour in the table, then cross-reference it to find the corresponding declination of the sun. Pay close attention to the letter next to that declination value. You must record whether this direction is north or south. This declination value is the essential coordinate for the math ahead. It anchors the physical time of your ship's observation to the exact celestial position of the sun. Now we calculate the true amplitude. We use this formula. The sine of the amplitude equals the sine of the declination divided by the cosine of the latitude. Let's plug in some example variables. We will use a latitude of 21.8 degrees and a declination of 11.1 degrees. Divide the sine of 11.1 by the cosine of 21.8. To isolate the final amplitude value, take the inverse sign of the equation's result. In our example, that calculation gives us exactly 12 degrees. A raw number is useless for navigation without a naming convention. We format this starting with a prefix. If you observed the sun rising, assign the prefix east. If the sun was setting, assign the prefix west. Then, assign the suffix north or south to exactly match the name of your recorded declination. For a sunning sun with a southern declination, our final format is west 12 degrees south. This diagram shows the celestial sphere. That formatted string we just built defines the sun's exact angular distance from the prime vertical. To use west 12 degrees south on a physical map, we must convert it into a standard 360-degree true bearing. Start at the cardinal direction indicated by your prefix. Since our prefix is west, we start at 270 degrees. Step 2. Move along the compass by your calculated degree amount, heading toward the suffix direction. In this case, moving 12 degrees south. We simply subtract 12 from 270, which reveals our converted true bearing of 258 degrees. This number represents the perfect, mathematically true bearing of the sun at the moment of observation, completely free of any mechanical ship error. Finally, compare your calculated true bearing of 258 degrees directly against the observed compass bearing you recorded in Step 1. Let's say your compass read 256 degrees. Calculate the simple numerical difference between the two bearings. 258 minus 256 gives us a total error of 2 degrees. To determine if that error direction is east or west, use the standard maritime mnemonic: compass best, error west; compass least, error east. Apply that rule to our numbers. Our observed compass reading of 256 is less than our true bearing of 258. Because the compass is least, our final determined compass error is exactly 2 degrees east. You have successfully transformed a visual observation of the sunrise into hard, actionable navigational data. The navigator immediately applies this 2-degree east error to adjust the ship's current heading. This ensures the helmsman is actually steering the correct true course through the water. By making amplitude calculations a standard daily watch routine at dawn and dusk, a navigator never has to second-guess the safety of their heading.